Hello everyone. In this video, I will be talking about some of the basic concepts about motion in a straight line or rectilinear motion. Introduction. Motion is a change in position of an object with time. If there is a perceived change in position of an object with time, we can say that that object is in motion. Examples of object in motions include the birds, the flies, etc., the planets which are in motion around the sun. Now, motion of an object in a straight line is called rectilinear motion. In this video, I will be discussing mostly this concept, that is motion in a straight line. We can see here in this figure, we can see a car going along a straight road. This is an example of a rectilinear motion. Now, we can understand some of the concepts regarding this rectilinear motion, which include path length, displacement, and position. Position of an object can be specified with respect to a point of reference or frame of reference. We can consider a point O as shown in this figure, with respect to which the position of an object can be specified. At first, let's consider a car as example. The car starts from the origin O, that is 0. After a time t, it goes to the point P. Then the total path length it traveled is 360 meter. The displacement is also 360 meter. Now from P, it goes to Q. Now the total path length is from 0 to 360, 360. Then from 360 to 240, it is 120. So 360 plus 120, 480 meter. While the displacement, which is a vector quantity, will be 240 minus 360, which is minus 120. Now the car goes to the point R. In this case, the total path length is plus 120 plus 360 plus 120, that is 240 plus 360, which will be 600. While the displacement from Q to R is minus 120 minus 240, which is minus 360. In this case, we can observe that the sign is used to show the direction of motion. That is, in displacement, we have considered negative as the motion in the left hand side, while positive the motion to the right hand side. This is what is considered in the case of a rectilinear motion, since the motion takes place either towards the right side or towards the left side. Now we can see the concept of average velocity. Average velocity is defined as the change in position or displacement divided by the time intervals in which the displacement occurs. The average velocity can be positive or negative depending upon the sign of displacement. It is 0 if displacement is 0. Average velocity is also a vector quantity like displacement. These are some of the graphs which are showing different types of velocity. First graph shows the case of positive velocity. The second graph shows the distance time graph for negative velocity. And the third graph shows when a body is at rest. Now average speed. Average speed is defined as the total path length traveled divided by the total time interval during which the motion has taken place. This is a scalar quantity, just like path length. Now, average speed is always positive, since it does not tell the direction of motion. Instantaneous velocity and speed. Instantaneous velocity describes how fast an object is moving at different instants of time in a given time interval. It is also defined as average velocity for an infinitely small time interval. So, instantaneous velocity gives the velocity of an object in motion at a very small instant. That is, the time interval is very infinitesimally small. So, we can express this by this equation. That is, v instantaneous velocity is equal to limit delta t tends to 0 delta x by delta 2 delta t is equal to dx by dt. Instantaneous speed or simply speed is the magnitude of velocity. Now acceleration. Acceleration is the rate of change of velocity with time. It is denoted by a and the SI unit is meters per second square. The average acceleration or a time interval is defined as the change of velocity divided by the time interval. Acceleration can be positive or negative. Since acceleration is also a vector quantity, it has also got sign. These are the graphs for different kinds of acceleration. First, for distance time graph for positive acceleration. Second shows for the case of negative acceleration, and the third shows when acceleration is equal to 0. When acceleration is equal to 0, the motion is called uniform motion, since the body travels equal distances in equal intervals of time. Instantaneous acceleration. Instantaneous acceleration is at different instants of time. Acceleration at an instant is slope of tangent to the velocity time curve at that instant. And it is given by limit delta t tends to 0 delta v by delta t, that is equal to dv by dt. Now, kinematic equations of motion. There are basically three important equations of motion for uniform acceleration. These are v is equal to v0 plus at, where v is the final velocity, v0 is the initial velocity, a is the acceleration, and t is the time period. This is the second equation, which is x is equal to v0t plus half at square. Here x is the displacement, v0 is the initial velocity, t is the time taken, and a is the acceleration. And this is the third equation, which is v square is equal to v0 square plus 2ax. Now, relative velocity. The relative velocity of an object A with respect to another object B is the velocity that object A would appear to have to an observer situated on object B moving along with it. Let us consider some of the cases. In this case, velocity of both the bodies are equal. Then we get the distance time graph as shown in the figure. First, that is VB is equal to VA, then VB minus VA is equal to 0. Then second case is VA greater than VB. In this case, VA and VB meets at a point. VA has got a much steeper slope than B, and VB minus VA is negative. When VA and VB are of opposite signs, then VB goes negative and VA goes towards positive. That is, in the case when two bodies are traveling in opposite direction. Consider the case of two trains. One train is traveling towards left side with 100 kilometers per hour, and the other is traveling towards right with 60 kilometers per hour. Then the relative velocity is given by 100 plus 60, which is 160 kilometers per hour. If both the trains are traveling towards the same direction, that is, one is one train at 100 kilometers to right and the other also towards the right with 60 kilometers, then the relative velocity is given by the difference between these velocities, that is 100 minus 60, that's equal to 40. If these two trains are traveling with equal velocities, then the relative velocity is 0. Hence, for the observer, the other train is seen to be at rest. And this is the end of this video. In this video, I have just given a brief description about some of the basic concepts of motion in a straight line or rectilinear motion. If you have got any doubts regarding any of the concepts discussed in this video, please comment in the section below this video. Thank you.